Hello, welcome to the study of ODE, non-homogeneous case. We are looking at the linear ODE, which has variable coefficient. So x squared, y double prime minus xy single prime plus 4y is equal to cos natural logarithm of x. So to do this, we are going to let x squared, y double prime to be equivalent to d into bracket d minus 1y, and xy single prime to be equal to dy, then x to be equal to exponential t, so that now we have natural logarithm of x is equal to t. So we make this substitution here so that our OD now becomes d into bracket d minus 1 y minus dy plus 4y is equal to cos of t. So this is d squared minus d into bracket y minus dy plus 4y is equal to cos of t. Meaning that d squared minus 2d plus 4y is equal to cos of t. Note that this equation now has become an homogeneous ODE with the constant coefficient, and it has two parts. So we start with the y complementary, which is equal to d squared minus 2d plus 4. This is equal to 0. And this one is a quadratic equation whereby we can solve it here. We are going to let our y to be equal to exponential mt, so that now we get our y prime to be equal to m exponential mt, our y double prime to be equal to m exponential, this is m squared. So d here stands for derivative with respect to x, d squared stands for second derivative with respect to x squared. So substituting, we shall have m squared minus 2m plus 4, which is equal to 0. So by quadratic formula, m will be equal to 2 plus or minus 4 minus 16 divided by 2, making use of quadratic formula. This is equal to 2 plus or minus 2 into bracket 3i divided by 2. So our m is equal to 1 plus or minus root of 3. So our y complementary, root of 3i. Our y complementary will be given by exponential t into bracket c1 sine of root 3t plus c2 cos of root 3 t. We close the bracket. So that is our y complementary. Then we jump to our y particular. Y particular will be given by cos of t divided by d squared minus 2d plus 4, which is equal to cos of t divided by 1 squared minus 2d plus 4. This is equal to cos of t into bracket 3 minus 2d. This is negative 1 plus 4, which will give you 3. Then yp is equal to 3 plus 2d cos of t divided by this part here, 3 plus 2d multiplied by 3 minus 2d. I am multiplying by 3 plus 2d, and I have divided by 3 plus 2d, which does not change. So d means we differentiate. So we shall have 3 cos of t minus 2 sine of t, differentiating cos with respect to t. This will give you 9 minus 4d squared, which is equal to 3 cos of t minus 2 sine of t divided by 9 minus 4 into bracket minus 1. We square that part. So our yp will be equal to 3 cos of t minus 2 sine of t divided by, this is 9. This part here, we are going to have 9 minus 4 and minus 9 minus 4 and minus 1, which will give you plus, so we will have 13. So which is equal to 3 over 13 cos of t minus 2 sine of t divided by 13. Now, our y will be given by y complementary plus y particular, which is equal to exponential t into bracket c1 sine of root 3t plus c2 cos of root 3t, close the bracket, plus that 1 over 13 into bracket 3 cos of t minus 2 sine of t. Now, we remember that x is equal to exponential t, and natural logarithm of x is equal to t. So we make those substitution so that now our y will be equal to x into bracket c1 sine of root 3 ln of x plus c2 cos of root 3 ln of x, we close the bracket, then plus 1 bracket cos of ln x minus 2 sine of ln x, we close the bracket. So this is the solution of our given ODE, which was x squared y double prime minus xy single prime, which is equal to cos of ln of x. So this is the solution of our given ODE, our general solution. And I request you to tune on to my YouTube channel so that you don't miss a single video as we continue learning more of ODE. Remember also to subscribe to this channel and also to share with the other mathematicians so that we may keep on learning. May I also have a comment concerning this study? If there is any other area which you want us to focus on, let me know, and I'm going to tackle it for us. Bye bye. See you in the next video.